Now we have with us Martin Pugh, who will be discussing how we get weights right in Polkadot, how we benchmark 3 separate runtimes quickly and accurately. Martin?
Yeah, hi guys, how's it going? It's been a great conference so far. So as Bill said, my name is Martin. I'm the release manager at Parity. So I primarily handle the releases of Polkadot and Kusama, their node software, as well as their runtimes, and Polkadot's test network, West End. So a big part of the release process, or a part of the release process, involves making sure that the weights for these 3 runtimes are accurate. And in this talk, I'm going to give a fairly brief introduction to what weights are, not a comprehensive talk on weights by any means. I'll explain why they're important, and finally, I'll show you how we get them right in Polkadot, Kusama, and West End. So, what are weights? Every transaction in a substrate-based chain has a weight associated with it. For instance, sending tokens from one account to another, bonding and unbonding, taking part in democracy, etc. All of these have a weight associated with them. These are essentially an abstract concept developed to represent the I/O and computational complexity of a particular call. So, for example, calls that make lots of storage queries and perform lots of heavy CPU calculations are going to have a higher weight than ones that don't make such a heavy kind of task, I guess. And each block in a substrate-based runtime has a maximum block weight. So the sum of the weight of all these transactions in a block can't exceed this limit. And that's how we limit the amount of work done in a single block. So we can't continuously fill up a block with billions and billions of transactions. Once we exceed this block limit, that's it. It's quite a bit more complicated than that. But again, this isn't a deep dive into how weights work. I'm going to post some links at the end of the talk that will go into it in a more deep dive. And there are some links in the Discord that will, again, go into how weights work in a lot more depth. A talk by the last talker, Sean, and I think a talk at last Sub0 by Gav as well. So what weights look like? In the Polkadot project, that is the repository that hosts Kusama, Polkadot, West End's code. Weights are in a directory nested in the runtimes directory for each runtime. So the directory for Kusama, West End, Polkadot. And here's what weights look like. It's not tremendously useful, this knowledge. It is just kind of useful to see that weights are not just an abstract concept, they are computer code. So on the left, you can see that these are some weights for the balances palette in Kusama. And then on the right, you can see that they relate to some kind of fee. So when you conduct one of these various calls, that weight will get turned into a fee on chain, somewhat similar to Ethereum's gas, but calculated somewhat differently. It's not done on a per operation basis. And again, the relationship between the weights and the specific fees, like the actual specifics, don't matter so much for this talk. I just find it useful to show the concrete thing. This is computer code we're dealing with. So each palette for each runtime will have its own weights associated with it, and then within each block of code, there's a weight for each call. So new code's added to Substrate all the time. On Polkadot and Substrate, we're managing I don't know, 10, maybe 15 closed PRs a day. So the pace of development on Polkadot is high. So each time, we're getting new palettes are added, old code is updated and improved, lots of things change. So in order to get accurate weights, we need to go through a process called benchmarking. This process essentially comprises of repeatedly running calls on a standard piece of hardware, which I'll get into later, and averaging the results, replacing the old weights with the new results of this benchmarking process. And benchmarking happens in 2 situations. During development, developers can utilize a tool called Benchbot, which I'll get onto later, to run benchmarks of individual palettes they're working on, which is a really useful tool for, so a dev's working on a palette and they want to know that the changes that they've made to a particular palette isn't going to increase the weight of a call by a certain amount, or that conversely, they expect that the computational complexity of a call will change and that gets reflected in the weights. And that's really useful. But for releases, we want to ensure that all of the runtime weights are correct and accurate for that particular release candidate. So this requires running benchmarks for every call, for all palettes, for all 3 runtimes. This operation takes some time to complete. but it's absolutely critical for the security and correctness of the chains. So I mentioned BenchBot. This is a tool that can be utilized by developers by way of making comments on a GitHub pull request. It's a tool developed in-house, pulling benchmarks on an individual palette for a single runtime. So they interface via GitHub with developers interface with BenchBot via GitHub pull request comments, and BenchBot will go off and do its calculations in the background and commit the updated weights back to the developer's PR. This is a quick screenshot of one of our developers calling it on the vesting palette in Kusama, and you see they made a comment, and then the BenchBot's gone off in the background and calculated the new weights, and it would have committed the new weights to his pull request. And there'll be a link at the end of the talk to BenchBot source code if you'd like to introduce it to your own project. So earlier, I also mentioned reference hardware. It's very important that when we run benchmarks on this, that when we run benchmarks, we're running them on the same hardware every time. After all, if we've got faster storage, faster memory, faster CPU, then you'd expect the weights to be lower for the same amount of computation done. It executes faster, you get a lower weight. For this, we use OVH's Rise 2 dedicated server. The server specs are up there if you'd like to just like look at them. Believe we've changed the reference hardware once before, which obviously involved updating all of the weights. So it's possible that this could happen in the future as well as computation hardware develops. Also, as an aside, I believe this is a really good example of a good node to run a validator from. Don't quote me on that. I'm sure someone from DevOps would very much disagree, but I think it's a good example of a good machine to run a validator on. So as I mentioned, running benchmarks for a release is very different from the process used during development. It involves recalculating all the weights for every call for 3 runtimes, Kusama, Polkadot, West-End. So at Parity, we generally use GitLab for larger, longer running CI jobs that we want to run on our own hardware. This allows us to specify the exact hardware we want to run jobs on, so we can use the aforementioned standard hardware. Even on fairly high-spec machines, Substrate and Polkadot can take a while to build, so it's useful to be able to, throw hardware at the problem. So we've got 3 of these OVH machines reserved specifically for running benchmarks. When we're not running benchmarks, they're not doing anything. 1 for each runtime. When we want to start a benchmark for a runtime, i.e. when we're beginning a release, we initiate a manual CI job against the release branch or master, whichever makes sense at the time. And these benchmark jobs can take several hours to run. I think this depends on the amount of pallets in the runtime. So, for instance, Polkadot until recently didn't have the parachains palette, so it took a lot less time to run than Kusama and West-End. Thankfully, now we've added the parachains palettes to Polkadot, so they're taking about 12 to 13 hours to run these benchmarks. So that's why I prefer to run them in parallel rather than using a single box one after the other. As I mentioned, throwing hardware at a problem, great solution. When the jobs are complete, they'll return a git patch file as the job artifact, which can be downloaded and applied to the release branch, which sounds really old school, like shipping git patch files around, but it's really effective as a technique for not having to have bots that automatically commit to branches, particularly important branches like release branches. So yeah, it's really useful, and it feels a bit old school and fun. So for those curious to see how benchmarks are actually run, you can see it in this image here. Hopefully the video quality is high enough to see my tiny text editor. It's essentially a subcommand of Polkadot or the Substrate node template, I think it's called, when it's built with the benchmarking feature enabled. This snippet is from a script that can be found in the Polkadot repo. Again, I'll post a link to it at the end of the slides. And it shows you the steps and repetitions of the benchmarking we do. So for example, this will run the same benchmark 20 times in 50 steps. I can't quite remember specifically what steps are differing from repetitions, but yeah. As well as a few other useful flags. So for instance, the header flag lets you have arbitrary text at the top of your weights file. If you remember previously, we had that that file that actually had the weights in it. So we use this for shoving the license slug at the top of the file, the GPL v3 license slug, and the location to put the generated weights code. We just overwrite the weights file, but I suppose you could send it to a different file and compare them side by side or something like that. So what are the observations and lessons that I've learned from setting up this benchmarking setup? Initially, when I set up the GitLab CI runners on a benchmarking machine, I used our default CI configuration, which was to run the benchmarks in Docker containers. Ubuntu 1904 or 1804, whatever it is, I'm not quite sure. I didn't think anything of this. As far as I'm aware, Linux namespacing used by Docker is a zero cost abstraction. But it turns out we were getting benchmarks that didn't quite look right. Sean mentioned to me once that he'd previously struggled with this, so I looked into it, removed Docker from the equation, and had GitLab runners just run the benchmarks as a shell command. And sure enough, the benchmarks returned to what we thought were the correct values. So still not quite sure what that is. I think it's something to do with volume mounting, but I'm not quite sure. Secondly, all benchmarks aren't created equally. In the Substrate docs that I've linked at the end of this talk, there are some documents on how you can integrate weights into your own project. And if you read that, you'll see that the developer's given quite a lot of freedom in writing their benchmarks. So the precise calculations it does for generating them, which means that as a result, palettes can take different times to complete. This is just something to be aware of when you're running a whole benchmark. Sometimes a seemingly small change can change the time it takes to do a full benchmark from 1 hour to 2 hours or something like that. And again, having a dialogue between yourself and your developers can really help you in being aware of these things. And finally, I mentioned that what gets spit out at the end of the benchmarking process is a big Git diff. We're currently working to develop a tool that will kind of go through all of these updated weights and determine, oh, this is twice the weight it used to be. Why is this? And things like that. But currently, it's kind of a manual process. We know what code's changed where, and we can somewhat intuit whether that would change a given weight. That being said, there can be base changes, for instance, to frame or something like that could cause weight changes to palettes that have otherwise not been changed. You kind of have to use your intuition and experience sometimes when determining whether a change to a given weight is expected or not. Or if you may ask a runtime engineer, the devs know what code they've been working on, and they're always welcome to help out and let you know if they've been working on a particular palette. And, oh, by the way, the weights for this are going to change drastically. And so with that, I will bring my talk to an end. Again, at the bottom there, I've got some links to the transaction weights page in the Substrate wiki. The source code of BenchBot, which again is a tool that can greatly assist you in adding benchmarking as a CI process to your own project. And finally, the Polkadot benchmarking script, which you could also lift and use for running all of the benchmarks for your release. And with that, I will take any questions.
Okay, thank you very much, Martin. Just as a reminder, please go to the Q&A tab to enter your questions. So I'm curious, how did you determine the reference hardware, and when will you decide to update that? You said it's happened once in the past. Is there once it gets so slow, or compared to the latest offerings from OVH, what's the rules for that?
Yeah, I wasn't involved heavily in benchmarking when we switched to the new reference hardware. So I actually honestly can't tell you the restrictions, but I would imagine it will be a case of when the offering that we want to use is no longer available from OVH, or as so many generations of computational hardware are introduced, it starts looking like the hardware we're using isn't a good representation of standard hardware, I guess. I think that's the thing, is that it being standard hardware that's used widely and is widely available is probably one of the most important things.
Just what, I guess, yeah, it's sort of a sort of back and forth with the community, like what are they using for hardware for
Yeah,
validator nodes
exactly.
and
Yeah,
things.
which might actually have been how the original or the current, sorry, I should say, reference hardware was decided. Right, it needs to be regularly available. There's no point using a machine that's super obscure and hard to get hold of as your reference hardware, because then it's not representative of what hardware people are running our software on.
Right. So I'm also curious. You mentioned like that you would run these. I forget exactly how many times, right? But multiple times for each function to get the weight. Like, how much variance do you see in these individual runs? Do they tend to be pretty similar, or does it actually fluctuate greatly?
Yeah, it's a great question. So actually, I mentioned we had an issue with Docker volumes potentially causing an issue with the weights, and that was actually found because the weights for the balances palette, which is never touched. Balances is a fairly static palette. They were out by I think about maybe 10% or something like that. And I think it was Sean that pointed out to me, no, these weights don't look so. This palette doesn't get touched, blah blah blah. And again, this is having developers on hand to let you to inform you of when there are notable changes. But yeah, like for an untouched palette between runs, you see very low variance, like less than 1%.
Oh, okay.
And yeah, so we tend to run them like I think 50 times or 20 times per call, and these machines again aren't doing anything important the rest of the time, so you do get fairly consistent results. Yeah, I would say less than 1%.
Okay, yeah, all right. So we have a question from an audience member. Were there any cases where you decided to manually change transaction weights after benchmarking?
Manually, as in typing in the like manually editing the text
Yeah.
file and updating the weight. Not that I'm aware of.
Right.
All of the since all of this work has been done in the substrate benchmarking, I think it's a crate feature. It's all done by these weight calculations. I think for some, when palettes are initially being written, if they've not had benchmarking implemented yet, they'll have placeholder weights. But once we actually have benchmarks implemented, no, it's all done automatically.
Okay, and that's been implemented for, I guess, as long as you've been here.
Yeah, but at least for the last year, probably longer than that. Yeah.
Okay. All right. Well, thank you very much, Martin. We really appreciate learning a little bit more about weights and how we benchmark weights for runtime releases.